Okay, so now we are discussing KAKB, ionic equilibrium, MCQs that are there in our view, in page number 21, 22, and 23. Okay, so those are new syllabus past paper questions. We'll see how to answer those MCQs, right? And we start from 2020, 2019 A level MCQ. 2019 A level MCQ. This one. So it says for a weak acid, it can be given that F F equals amount of acid dissociated over amount of acid undissociated. That's a fraction. Yeah, and they're asking the relationship between log of that fraction and the pH. Okay. So now, how to think about that one? Now, this is the weak acid now. Weak acid. So, if it is a weak acid now, we all know we'll take it as HG. It can undergo ionization and give you H3O plus and A minus. Understood? H3O plus and A minus is the equilibrium. Okay. And you can understand. We have a Ka expression for this one. No? Ka. What is the Ka expression? H3O plus into A minus and HA. So these things we all know. These things we all know. Very clear, like Ka expression. Can understand. Now it says amount of acid dissociated and amount of acid undissociated. Now, if you apply ice method to this one, the dissociated amount is x naught. Remember, and it will give you x of this and x of this. Understood? Then the amount of undissociated is what? That c minus x remain at the end. Understood? So amount of acid dissociated. This is x. Dissociated acid. And c minus x is the what? Undissociated amount or undissociated concentration of acid. Is that clear? Those two. That means, right? So in this Ka expression, you can link them. A minus concentration and HA concentration. Isn't it? Huh? So in this expression, now you can convert this. Ka equal A minus concentration over HA concentration into H3O plus. You can change it like this, right? And then you can take it into log, minus log K, minus log A minus over HA, and plus minus log H3O plus. So minus log Ka is what? Pk. This one is actually the same thing, A minus over H. And this becomes pH. So if you subject the pH, yeah, what will you get? The Henderson's equation. So if you just quickly think this is the Henderson's equation, it is really easy to do the question. Okay. So pKa plus log A minus over H. Right? Henderson's equation. Now I told you earlier, Henderson equation is not used only for buffers. It can be used anywhere. Question like this, they are using Henderson, but this is the buffer. Right. So anyway, now this is your dissociated amount and this is your undissociated amount. Isn't it? So now simply that means this fraction is what actually given there as f. Isn't it? Log f. So this is your log f. So you can write this equation again. pH equal pK plus log f. Then plus log f. Now you need to put them in y equal mx. Sorry, into this y-axis and x-axis format. So in y-axis you have log f. So if you change it again, you can say log f equals pKa. You can say pH minus pKa. Okay, so this is your y-axis, this is your x-axis, and this is your what? But we intersect. Right? Intersect. So this is y equal mx minus c graph. Okay, so this is a straight line. It is a straight line and have a positive gradient. Should be bended to the right. And then it will have a minus intercept. So the graph will look like this. And this is your what? P A A. Understood that question? Huh? So I sort of told you the derivation also. Anyways, simply asking what is A minus and what is HA. A minus represents the dissociated amount. HA represents the undissociated amount. Simply is F. This part is F. No, this part is F. So then change the equation and get this pH, log F and everything. And finally you can make it into the graph format, y-x format. You got the idea? What is the correct answer also? Anyway, now you understand. Okay, now there are some space left. Don't use the whole space for writing this thing. That space is given for something else. The next question. And because that's a very good question. Okay, so manage your space there and show. I think writing this is enough. Okay? Writing this Henderson's equation and then telling this part is F is enough. Okay, and show how it becomes y equal mx minus c. Online students, did you understand it fully? Any doubts? Okay, next question. 2019 level MCQ 21. Now the thing is now this question, and I'm going to show you one more question. 2021 A-level 2021 A-level MCQ 24. They both are very good questions. Okay, you can consider these questions to be the kind of most difficult within these questions are there within the most difficult 5 questions in the paper. Right? Try to understand. Okay? Try to understand. It's not that much difficult once you understand the theory, but to try to start this question, most of the time students are getting lost, don't know what to do, and trust me, right? We'll see how to do it. Huh? Okay, now I'll share the question. 2019 question we will first do. It says a buffer solution of pH 5 was prepared by mixing equal volumes of 0.1 monobasic weak acid and 0.1 solution of sodium salt of this acid. Okay, first of all, they are telling us about a buffer. Okay, buffer. So that's a buffer. So to make this buffer, they have added 2 things. What are the 2 things? 0.1 N HA, let's say B volume, B centimeter. And equal volumes. And from this, let's say NKA or A minus, you can say A minus. You add in the same concentration, B centimeter. Now in this volume, you have 2 B centimeter cube. Now in this solution, you have HA and both A minus. That's why we can say that this has a buffer. Like that, we can put a small diagram to explain this. Because knowing that V volume is added is important. And knowing that the total volume is 2V is important for this question. That's all. And what is the pH value here? pH value is 5. Right? Then it says the pH of the resulting solution when 20 centimeter cube of this buffer solution was mixed with. So this is to take 20 centimeter cube of this buffer. 20 cm cube of this buffer. That means you have both HA and A minus. Right? And mixed with 90 cubic centimeters of. Now you are again adding 90 centimeter cube. Now you know the volume. 90 cubic centimeters of HA, 0.19 concentration. So they are asking, now you get another solution, no? Right? They are asking the pH value of this new solution. That's the question. Now you can make it a bit okay by drawing a small diagram. And show the information. So that's the trick. That is the trick. Okay? Right now, Now you can see in several places they have given concentration and volume. Now what you can do with those two data? You can find the number of moles. Now we'll find. So how many moles are there? How many moles are there? Here you have 0.1 into V moles. V over 1000. Here you have the same number of moles, 0.1 into V over 1000 moles. Understood? These are the number of moles you are adding. And those moles are right here. Understood? Okay. Now, what is this pH file? Now, let's discuss that part regarding that solution. So, for buffers, we have Henderson. What is the Henderson equation? pH equal pKa plus log A minus concentration over HA concentration. Now, if you apply this equation to this buffer, the original buffer, right? What is going to be happening? 5 equal, we don't know the pKa value. 5 equal log. Now, you can apply the concentration of HA and A minus. Now, here, this will show you how it is coming. Right? So, what is the A minus concentration? 0.1 into B into 10 to the power minus 3 is the moles. And what's the total volume? 2B into 10 to the power minus 3. Isn't it? That is the A minus concentration. And you can see the same thing will be written for what? Same thing will be written for HA concentration. So no need to write this, but I'm going to show. I don't want this to show you that this is happening. Okay, so simply try to understand since the moles of HA and A minus are equal, what will happen? These two will get cancelled. So log 1. What is the value of log 1? 5 equal pKa plus log 1. What is the value of log 1? Log 1 is 0. So that means your pKa value is 5. Next, pKa value is 5. That is the data you can extract from the first statement. Is that clear? pKa 5. Okay, now you are taking 20 centimeter cube. You are taking 20 centimeter cube. Now let's find out how many moles of HA and A minus are there. So now the total HA moles will be the HA moles added from the two situations. And here also you are adding some HA moles. And for this one, you have another some amount of A minus moles. So now let's find out A minus and HA moles. So first find out A minus moles. A minus moles here. How many moles will be there? So now you have 0.1. Okay, now before that, I'm going to make it more somewhat easy. Now, after you are mixing this, what will be the concentrations of these two? The new concentrations of these two. Now, anyway, if you simplify this, what is the value you are going to get? You are going to get 0.05. Here also you are going to get 0.05. Those are the concentrations. Now, let's use those concentrations directly. Because you are getting 20 centimeter cube from that. So A minus moles 0.05 into 20 into 10 to the power minus 3. That means how many moles? How many moles? 0.5 into 1. 1 into 10 to the power minus 3 moles. That is the number of moles of A minus. Now, HA moles. HA moles, you have two things. This value comes again 1 into 10 to the power minus 3 moles plus the value coming from there. 9 into 10 to the power minus 3. So what's the total moles of HA? 10 into 10 to the power minus 3 moles. Is that clear? Is that clear? So this comes right. Understood? And these two values are same from this solution. Get the idea properly. Huh? So this is the total HA moles. Now again you are using what? Again you are using Henderson's equation. pH equal pKa plus log A minus O concentration over HA concentration. Now your pH is equal. What is the pKa value? You found it 5 and log. Now A minus concentration is 1 into 10 to the power minus 3 over B total. Just like showing you how to do it like you say. Right, we totally we cancel in MCQs. Right? And HA concentration is 1 into 10 to the power minus 2, or you will say 10 into 10 to the power minus 3 over B total. Understood? So if you simplify this, it will be 5 plus log 1 over 10. Log 1 over 10 is minus 1. Okay? Minus 1. So 5 minus 1 is 4. This is the pH level. The new pH is a clear. Good question. Good question. Online students, did you understand the question? 2019 A-level question. Is that clear? Okay, any doubts on this? No. Okay, shall I give you a few minutes to write, note down this? Okay, before that. Okay. So you can eliminate some answers. Okay? A-level exam, you can eliminate some answers. Now look at this one. Given values, now you know definitely pH 5 will not come. And now since you are adding acid, now you are adding acid mode, 90 centimeter cube of acid. So pH value should be lower than 5. So your answer 4, 5 can be ignored. Understand? So then you have to select one from either pH 3, 4 or 4.5. Okay? So you can eliminate two answers easily. But anyway, to get pH 4, you have to do the question. First part is given for you to find pKa, and second part is given for you to find moles and go to the Henderson method. Okay, write a good review in that space and make sure you study that one. That's why I left some space. Okay, now shall we write the whole thing and study this properly? Any doubts? Yeah, no. We are doing it for two parts only. First, you are finding pKa, then you are finding the new pH. Study, it's a good practice. Right, so I'll give you a few minutes to write down this. Okay, now let's look at the 2021 A-level. There's a similar question to this. See, a buffer solution at constant temperature contains a monobasic weak acid. Ka value is given and its sodium salt. The concentration of weak acid and sodium salt in solution are 0.1 each. That means pH equal pKa. Right? And the volume of 1 mole per decimeter cube of weak acid that should be added. They are asking for a volume from the weak acid. If you want to change the pH of 10 centimeter cube of this solution by 1 unit. So when you are adding the acid, what will happen to the pH? It will get decreased. Okay? So initial pH will be 5 and the answer should be lesser, some number lesser than 5. So you can eliminate the answers 2 and 4 easily. Okay? You can eliminate the answers 2 and 4 easily. So then you want anyway you can understand the final pH value is 4. Right? So the thing is this now, less than 1. Changing by 1 unit means final one should be 4 anyway. Right? And then the one you need to find here is the volume. How much volume you should add from that weak acid? Is it 9 centimeter cube? Is it 10 centimeter cube? Or is it 11 centimeter cube? Right? Got any answers? Alima? Sir? No luck. Okay, we'll see. We'll see. Kind of similar to the earlier question. Huh? Right. So it is a buffer. So it is a buffer. So the two volumes are HA and A minus. Concentrations are 0.1 0.1 and this concentration is also 0.1. Ka is given 1 into 10 to the power minus 5, so that means pKa is 5. pKa is 5. So if you apply Henderson's equation for this solution, pH equal pKa plus log A minus OHA, since their concentrations are same, you can say pH equal pKa equal 5. So then you can say when HA is added, okay, when HA is added, pH decreased by 1 unit. So therefore, final pH should be 4. But you can understand. And then let's see how we can make that into 4. So they are going to take 10 centimeter cube volume. 10 centimeter cube volume. Here you should have HA and A minus. HA and A minus. So you are adding HA now. So A minus moles are not changed. That means the moles will be 0.1 into 10 into 10 to the power minus 3 moles. Okay, and you are adding some amount of HA. Don't forget that. Let's say from 1 solution you are adding 3 centimeter. Now already you have 0.1 into 10 into 10 to the power minus 3 moles. And you have to add that newly added moles. That means 1 into V into 10 to the power minus 3 moles. Is that clear? This is the newly added. That's why I said these two questions are quite similar. Okay. Clear? Then apply Henderson. pH equal pKa plus log A minus OHA. It's very simple. So your pH is 4, pKa is 5, log A minus concentration is 0.1 into 10 into 10 to the power minus 3 over total volume V. We don't know the total volume. And the HA concentration is 0.1 into 10 into 10 to the power minus 3 plus 1 into B into 10 to the power minus 3 divided by B. So this B and everything get cancelled. So you will notice that log 10 to the power minus 3 also get cancelled. You can say 1 over 1 plus B. Okay, log 1 over 1 plus B. equal -1. Look that one there. Okay, so if you remove the log part, if you remove the log part, 1 over 1 plus b equal 1 over 10. Okay. You do the antilog, log of -1 over 10. So then if you simplify, will you get 10 equal 1 plus b. So b equal 9 centimeter. Understood? Both questions are quite similar. That's why I didn't erase the value. Can see. Online students, is that clear? Understood? Any doubts? Both questions are really good on the practice. Remember, memorize. Okay? If I was you, I'll memorize this before go to the exam. It was asked 2 times in syllabus, tables, and asked again. Okay? Both questions follow the same pattern. Okay, now shall we look at this 2019 A level MCQ 22, page number 21. So it says there are 3 solutions. It says there are 3 solutions. B is a weak acid. Let's say it is J. And Q is an equimolar mixture of weak acid and sodium solvent. So we can name for this one J and A minus. That means it is a buffer. And then R, titration mixture at equivalence point. Titration mixture at equivalence point. When you are reacting this one with sodium hydroxide and HA, equivalence point, what will you get? You will get NaA and water. That means here you have A minus at equivalence point. So they are telling me when each solution is diluted by the same amount at constant temperature, what will happen to their pH? By diluting. It means you are adding water. Understand? Diluting means you are adding water. So when you add water for each of these solutions, they are asking what will happen to their pH. So to understand about pH and everything, you need a relationship. Okay, so when you are diluting, concentration decreases. No? So to tell what happens to pH, you need the relationship between concentration and pH. Then you can predict. Understand? So by looking at these 3 diagrams, you should be able to remind these simply. These are the 3 question types we did. Then what is the first one? First one is ionization. Mixed. Second one is buffer. Third one is hydrolysis. Isn't it? For each of these question type, you had a final simplified formula to apply in MCQs. Okay? For essays, we had a derived it by applying noise method, writing assumptions and everything. But ultimate equation you are getting in each question type, you need to remember for these sort of MCQs. Right? So I remember that one. So if it is ionization, then your equation is AA equals H3O plus square over C. If it is a buffer, it is Henderson. pH equals pKa plus log A minus over H. Okay. And this one, hydrolysis, it is Kw over Ka. Because it is a conjugate base, so Kb will be Kw over K equal OH minus concentration square over C. Okay. Now if you subject the concentration of this one, or sorry, the pH of H2O plus of this one, H3O plus equals Ka into C rule. Now think, during dilution, concentration decreases. So as concentration decreases, what will happen to this H3O plus? It should also decrease. So if H3O plus is decreasing, pH will go up. So if you dilute the P solution, then pH will increase. Okay? Now come to this one. Here, when you are diluting, both these concentrations are decreasing by same factor. Understood? Because they stay in the same solution, both decrease by same factor. So as a result, what will happen to the pH? pH, there is no change. pH has not changed. Also understand that pH is not changing. And then finally, you have this equation again with subject OH minus concentration. That is equal to Kw over Ka. Anyway, those are constants. You don't have to worry about them. Into C root. So if you dilute this, C is decreasing. As a result, OH minus is decreasing. So pH will decrease because the basicity decreases. So then what is happening finally? pH increases. Q, pH does not change as it is a buffer. And R, pH decreases. So what is the answer? What is the answer? Answer is decrease, no, increase, increase, not change, decrease. Answer 2, ne? Answer 2. Good. Okay, online students, did you understand it? Any doubts? Shall we try the next question? It is from 2020 A-level paper. So it says, weak acid HA concentration C and its acid dissociation constant is Ka. Which of the following expression gives pH? That's what they asked. So it's a simple conversion of this particular expression. 2020 MCQ. So you have this Ka expression, Ka equal H3O plus square over C. K equals square over C. Right? Now if you subject H3O plus, you get Ka into C square root. But you can write the same thing. Using half power. Power half C to the power half Z. Now it is easy to convert this into pH. What you need to do, minus log for the base 10, H3O plus. And then this half comes to the front. Then minus log Ka. And this one becomes an addition and minus log C. Minus half minus log C. Understood? So then what is this? Minus log for the base 10 H3O plus is pH. pH equal half pKa minus half log C. Because this minus sign and plus sign are getting same. Understood, Lama? Easy one on there. From 2020 A-level paper. I think the answer is answer 1. Yes. Answer 1. Ne? Okay. So after writing this, go to the next question. 2020, another question, question number 42. Okay, done. Shall we go to the next question? An acidic buffer solution can be prepared by mixing a weak acid HA with its sodium salt. Yeah, you can prepare. That's true, because if it is a buffer, there should be both HA and A minus. So first statement is true. What is the explanation of first statement? Should be the buffer action. Isn't it? Explanation of the first statement is buffer action. I'm going to erase this. Huh? So acidic buffer solution can be prepared by mixing weak acid HA with its sodium salt. So that one is true, because if it is a buffer, there should be both HA and A minus. So I'm asking, what is the explanation of first statement? Should be the buffer action. Buffer action means you have to explain what would happen when you add strong acid, when you add strong base. You have to say the response of this system. So when you add HA, what will happen? So when you add a strong acid, what will happen? The conjugate base A minus will come and react. When you add a strong base, the conjugate acid HA come and react. And the balance the medium. So look at the next statement. When OH minus and H plus ions are added to a buffer solution, the added amount of OH minus or H plus ions are removed through the reactions. Yeah, that is also correct. And answer is answer 1. Isn't it? So now give the name buffer action for those two reactions. Okay, those two reactions are representing buffer action. Buffer action. Okay, the next question is also a good one from 2021 paper. MCQ 13. It's asking elementary reactions. It's kind of a rate related question. Give it a try. Okay, now look at this 13th MCQ. Elementary reaction A reacts with H3O plus to produce B. A reacts with H3O plus to produce B. Now it says it is an elementary. Elementary. What is the meaning of elementary reactions from kinetics? They occur in only one step. So what is the special thing regarding this one step reaction? We can easily get the order, right? Because order is equal to stoichiometric coefficient. Okay, so you can easily write then a rate law for this reaction. What is the rate law? Rate equal K, concentration of A and H3O plus concentration. There are solids here, so it comes in the equation. Overall order is 2. Overall order is 2. And it says, which of the following graphs is correct to represent the relationship between log rate and pH at a constant concentration of A? So now it says concentration of A is constant. If this concentration of A is constant, then you can say K, let's say this is K dash, or let's say K. K into A concentration you can consider as K dash. Okay? Then you can say rate equal K dash X3O plus concentration. You can get this relationship now. So now again you need pH now. So whenever you need pH, take minus log for the base 10. That's the only option. Right? So now let's convert this whole thing to minus log for the base 10. Okay, so minus log for the base 10 rate, minus log for the base 10 K dash, plus minus log for the base 10 X3O plus. Now don't simplify carefully. So otherwise you can't write it as pH. So then minus log rate equal minus log K dash plus pH. So now in your graph, in your graph it is log rate is there, but it should be given in plot class. So let's multiply this whole thing by minus 100. Then it will become log rate equal minus pH plus log K dash. Okay. So then this will look like what type of a graph? Y equal minus mx plus c graph. So minus gradient is negative. So then the shape of the graph is what? It should be a negative gradient with positive intercept. This is log K dash. Log rate pH. Okay, so what's the answer? Answer 5. What the answer? Now, okay. Anyone? Understood? Everyone? Answer is answer 5. Okay, and there's another 2021 level question. That page, discuss that too. What is that? When strong acids are hydrated with aqueous ammonia, a neutral solution is not obtained at the equivalence point. So, what do you think? Is it correct? What do you think, Hafsa? Is that correct? Will you get a neutral pH point, neutral solution at equivalence point? Yes? No, you will not. Why? Because neutral equivalence points are there for strong acid, strong base titrations. Right? Like that. Equivalence point will be neutral for SASB titrations. Equivalence point will be neutral for SASB titrations. So telling that we will not get a neutral value is correct. Because this statement is there correct. Okay, so you can explain why it is correct. Because when ammonia is reacted with a strong acid, so this is a weak base and strong acid titration, you will get ammonium chloride. This is the salt. This is the salt. Or you can take ammonium hydroxide, that is aqueous ammonia. Anyway, you will get ammonium chloride and water. Right? So this salt can fully ionize and give you ammonium ions and Cl minus ions. This ammonium ion, this is a weak conjugate acid, but this one is extremely weak. Remember, this is how we label this. This is extremely weak. conjugate base. So this is neglected. Neglected. So you have to think about ammonium. So ammonium can undergo hydrolysis, water to form again ammonia and H3O plus. So because of this H3O plus, at equivalence point, the solution will be acidic. The solution will be acidic. Exactly. Solution will be acidic. So first statement is correct. For the explanation, you need this hydrolysis part. This hydrolysis part. And look at the second statement. It tells ammonia. Ammonium can react with water, forming H3O plus. So that is a perfect explanation also. So you can take answer one. Answer one. Second one is also correct and it can explain too. So let's take answer one for the 2021 A level MCQ 49. You can see these questions are everywhere, even in the very middle of the paper, end of the paper, with questions like that. Okay, go to the next question. Two 2023 A level MCQ 12. MCQ 12. Okay, so I'm going to put a diagram for this one. Now it says we have a V1 centimeter cube volume of acetic acid and its concentration is x mol per deciliter. And there's another beaker. We have V2 centimeter cube. This says V2 is larger than V1. V2 centimeter cube of sodium hydroxide. Now this is a higher value. V2 is larger. It's a higher value. And it says the sodium hydroxide concentration is Y, and that Y is also a larger value. Concentration wise and volume wise, this is more. Okay, so that's going to tell you one thing. When these two solutions are mixed, what's going to be there at the end? Will it be a buffer? To become a buffer, some acetic acid should remain. According to this way, if you mix, you have more, but we have more sodium hydroxide and you have less acetic acid. So what will happen? Acetic acid will be fully consumed and there will be remaining some amount of sodium hydroxide. So what is this remaining sodium hydroxide moles? Because they react in 1:1 ratio. Acetic acid reacts with sodium hydroxide in 1:1 ratio. Form sodium acetate. And what you can apply ARR and see and it react as remaining, but simply it will be the difference. Right? So y into V2 into 10 to the power minus 3. Subtraction x into V1. This is the remaining moles of sodium hydroxide. But to decide pH or something, they are asking the pH. To decide pH, we need remaining sodium hydroxide concentration. To find that, we need the mole difference to be divided by the volume. Okay. So y into v2 into 10 to the power minus 3 x into v1 into 10 to the power minus 3 divided by the total volume v1 plus v2 into 10 to the power minus 3. So that 10 to the power minus 3 is going to get cancelled. So your final concentration is y v2 minus x v1 over v1 plus v2 in mole per decimeter. So, okay. So with this we know the OH minus concentration. And now we can find the POH. Now we can find POH. So POH is minus log for the base in this value. Okay. OH minus concentration. And then if you want the pH, it is pKW minus TOH. In other words, you can say pKW minus log for the base 10 OH minus concentration. Isn't it? Now you can simplify and put this answer here. Then what will be the answer? pKW plus log yv2 minus xv1 v1 plus v. A difficult question, right? Can manage this. pKW plus v2y v1x. The answer 2. Once 2. As I remember, there were 2 answers for this question. I think some other answer can be simplified to get the same thing. Let me check. This is from 2023 A level. 2023 A level. Yes. MCQ number 12. I think it is the wrong year. Maybe 2022. I is 2022 MCQ 17. Yeah. Can you change it? 2022 MCQ 17. 2022 MCQ 7. The answer is answer 2. Right. The answer, there's no other answer. Anyway, can understand it. And they can ask the same question as a buffer. What if they arrange this in the opposite order? What if they says what V1 is larger and X is larger? Then it is a buffer, because this will remain and some amount of sodium acetate is formed. Okay, right there, put a star and say if X was larger than Y and V1 is larger than V2, so in solution you will be remaining some acetic acid remain, and then there will be some amount of sodium acetate formed, and now the whole thing will be a buffer. Then the formula you are going to use is Henderson. The suitable question. Okay, now shall we go to the next question? There are 2 more questions. Let's quickly finish that then. Finish the discussion for today. Okay, what about the next question? A solution was prepared by mixing 100 centimeter cube of 1 mole per decimeter cube acetic acid and 100 centimeter cube of 1 mole per decimeter cube sodium acid. Now this is a buffer. Say it is a buffer, right? This is a buffer. And the resulting solution pH was 4.8. That means it is the pKa value. Right? You can say that too because if the concentrations are equal, pH equal pKa. 4.8 is the pKa. When a few drops of 0.1 HCl was added, now if you show the buffer action now, pH is still remained at 4.8. Okay. So the buffer action should be explained. So what is going to be reacting here? The conjugate base. What is the conjugate base? Acetate ion. Answer 2. Understood? Answer is answer 2. Easy, ne? You have to write their buffer action. Have you understood that question? It's an easy one. You need to remember this as a buffer. You need to tell about the buffer action. Okay, go to the next question. 2024 level. 2024 level. Methylamine is there. It's equilibrium, ionization equilibrium. Here it's asking Lewis acid Lewis base. Okay. Okay, now according to Lewis acid base concept, now they are asking acid base concept. According to Lewis acid base concept, what is a Lewis acid? The one that accepts the lone pair. Lewis base is the one that donates the lone pair. So methylamine is a Lewis base. Then the water must be the Lewis acid. And if you go to the other side, OH minus is the one that donates the lone pair. So then OH minus is the Lewis base. Okay, write that too. OH minus donates the lone pair. Therefore, it is the Lewis base. See questions, right? For answer this question, you have at least rough idea about the lesson. Always the difficult ones are coming, some easy ones are also coming. Now, anyway, in that case, H3 and H3 plus is the Lewis acid. Alright. So now what is the correct statement that telling that thing? 5. Methylamine behave as a Lewis base in forward reaction, while OH minus behave as a Lewis base in reverse reaction. That 123 level question is really and 124 level that next question, the one we did earlier. What was the answer for this question? About the polybasic acid, polyacidic base titration. Answer was answer 2. You can easily take the answer 3. You can easily take the answer by looking at the equivalence form. So that's what I want to show you today. All the questions are done, I think. They have time. So like this, I'll remind you all those lessons we did earlier, organic, starting from May, June, July, these 3 months. You plan a 3-month course to take A to A plus. Okay. Online students, I hope it is clear to you. Now write some reviews for these questions and practice again. I'll let this video separately to your WhatsApp groups so you can access it easily. And you can save the video if you want to watch it again. Like it separately. I did that the other one yesterday. Titration curve I added that invited and then this and separately keep it and stand. Okay.